Today, we're tackling the biggest story of all time. I mean, literally. We're going on a journey to the very beginning to explore the absolutely mind-blowing story of how everything, every star, every planet, you, me, how all of it burst into existence from a single point. So let's just start with the biggest question there is. How did all of this begin? The stars, the galaxies, our entire world. How did everything we know and see come from, well, nothing? That is the ultimate cosmic mystery we're diving into today. So where do we even begin our investigation? Well, science has a prime suspect, a powerful theory that traces all of creation back to a single, unimaginable origin point. And here it is, the Big Bang Theory. But, that name can be a little misleading. This wasn't some kind of explosion in space, like a firecracker. No, this was the expansion of space itself. Just try to picture this. All the matter and energy in the entire universe, everything, crammed into a space smaller than an atom at a temperature of trillions of degrees. That's our starting point. And when did all this happen? Well, all the evidence we have points to about 13.8 billion years ago. That's it. That's the age of our universe, the amount of time that's passed since that first rapid expansion kicked everything into motion. So how in the world do you picture the expansion of space itself? It's a tough one for sure. Here's a great way to think about it. Imagine you have a balloon, and you've drawn a bunch of little dots on it. As you blow up the balloon, all the dots move away from each other, right? But they aren't walking across the balloon's surface. The surface itself is stretching, carrying them apart. In this little analogy, we are the dots, and the fabric of that balloon, that's the fabric of our universe. Now, a theory this massive needs some serious evidence to back it up. You can't just make this stuff up. And luckily for us, the Big Bang wasn't a clean getaway. It left behind clues, these incredible cosmic echoes from the dawn of time that we can actually still detect today. Let's look at the evidence. First, when we point our telescopes out to deep space, we see that distant galaxies are all flying away from us. Their light is stretched out, or redshifted, which is the telltale sign they're moving away. This is called Hubble's law, and it's exactly what you'd expect in a universe that's expanding. The second clue, though, this is the real kicker. Scientists found this faint, uniform glow of radiation coming from every single direction in space, no matter where they looked. That faint glow has a name, the Cosmic Microwave Background, or CMB. And it was discovered almost by accident in 1964 by two astronomers, Arno Penzias and Robert Wilson. You can think of it as a cosmic fossil. It's the leftover heat from the creation of the universe, which is now cooled over billions of years to just a few degrees above absolute zero. It's the oldest light in the universe. It is, quite literally, a remnant of the intense heat and energy released during the initial moments after the Big Bang. It is the actual afterglow of creation. Discovering the CMB was an absolute game-changer for the theory. Okay, so the evidence all points to a universe that started out incredibly hot and dense and has been expanding and cooling down ever since. But how do we get from that primordial soup of particles to the incredible cosmos we see today? How do we get from that to galaxies and stars? Well, that initial expansion really set the stage for everything that came next. As the universe cooled, gravity could finally start to take over. It started pulling matter together into these tiny, dense clumps. Over billions and billions of years, these clumps just kept growing, snowballing into vast galaxies, igniting countless stars, and forming the planets that orbit them, including our very own. But you know what? The story is far from over. Understanding the Big Bang isn't just about looking into the past. It's an ongoing quest to understand the fundamental nature of our reality, right now. That quest to understand our cosmic origins is happening every single day. Scientists are using these unbelievable tools, from giant telescopes that can peer back in time to massive particle accelerators that actually try to recreate the conditions of the early universe. It's all about uncovering new pieces to this grand puzzle. And that brings us right to the edge of what we currently know. We have this incredible theory for how it all began, but in answering that one question, we've stumbled upon even deeper mysteries. What is this dark matter that seems to hold our galaxies together? What is this dark energy that's making the universe expand even faster? And what's the ultimate fate of it all? These are the big questions that drive us forward, deeper into the great unknown.